Hi, everybody. Welcome to section 4.7. This is our last section in chapter 4. We're going to talk about inverse relations. So let's start off by mentioning that an inverse relation is a set of ordered pairs obtained by switching the x and the y coordinates. So it really is as simple as that. Switch the x and the y. So the x becomes the y becomes the x. We switch the domain and the range. The domain becomes the range of the inverse, the range becomes the domain of the inverse. And we're going to look at inverse relations of ordered pairs, tables, graphs, and equations. So we've got kind of 4 things to mention. I think the first 3 of those 4 you're going to be like, got this. We just need to do a little bit of work with equations, and equations is going to go back to working on manipulating things, changing things, adding to both sides, subtracting, that section 2.8 stuff. So let's start with practice 1A. Find the inverse of each relation. So we just said on that last slide that the set of ordered pairs obtained by switching the x and the y coordinate. So instead of having 4, -10, our inverse would be -10, 4. Instead of having 7, -19, our inverse will be -19, 7. Notice the sign stays with that number. We just switch the x and the y, flip-flop those two things. Instead of -5, 17, we've got a 17, -5. And I'm pretty sure that you'd be able to figure out, instead of -3, 11, our inverse would be 11, -3. So this is the relation, the set of ordered pairs that I gave you. This is the inverse, the set of ordered pairs that we got by rearranging, by switching the domain and the range. We could put those in set notation. We do have to put them as ordered pairs. So for B, I'm going to give you a table. Notice the table is x's and y's. I'm going to write my inverse as ordered pairs again because that seems easiest. So notice this is a ordered pair, -4, 13. So the inverse of that will be -13, -4. Again, I just switched the order of those two values. My next ordered pair, -8.5 and -1. My next ordered pair for my inverse will be 0.5, 5. And the last part of my inverse will be 6.59. Seems simple, right? So we've done 2 of the 4. We've done ordered pairs. We've done tables. Now we need to talk about graphs. So number 2A and B, it says to graph the inverse of the relation. Well, I like to do this by using ordered pairs. So let's do 2A. And for 2A, I'm going to make an XY table for my original relation. So I'm going to pull some points off of here. Looks like these all have nice, neat grid marks. So I'm going to put some grid marks. Let's do 4 just so that we've got these. So this lowest point right here, farthest to the left, looks to me like it's a -2, -1. My next ordered pair looks like it's -1 and up 0. This one right here looks like it's over 0, up 1. And this last ordered pair that I did, and I could do more, but this should get me enough information, looks like it's over 1, up 2. So that's my relation. So if I want to figure out what the inverse is, I'm going to have 4 ordered pairs, and I'm going to do exactly the same thing as we just did. If my first ordered pair is -2, -1, my inverse, we just switch my x and my y values, so that would be -1, -2. My next ordered pair would be 0, -1. I'm just going to switch those two values. My next ordered pair, since it was 0, 1, I'm going to switch those and 1, 0. And my final ordered pair, instead of 1, 2, let's switch those and 2, 1. So I wrote the inverse, but it does ask me to graph the inverse. So once we got the ordered pairs, everybody's good with graphing those, right? So my inverse, my first ordered pair is -1, -2. My next ordered pair is 0, -1. My next ordered pair is 1, 0, and then 2, 1. Since it was originally a line, when I graph it, I'm going to make it a line. It just so happens to be parallel. It won't always be. If we did 2b, we wouldn't have a parallel line, but it just happens to work that way. But we know that we just graphed the inverse, so no problem with that. So now, next thing, find the inverse of a function or an equation. So that's the last thing that we need to know how to find the inverse of. So first of all, replace, if we've got our fancy f of x, put a y there. That way we don't have anything crazy. Like, for example, if I gave you an f of x equals x plus 3, I'm just going to make that a y equals x plus 3. So nothing fancy, just replace that. Next thing, here's where, just like we did in the others, we switch the domain and range or switch the x and the y values. We're going to flip-flop the variables. So I'm going to make the y into an x. I'm going to make the x into a y. So we still switch the x and the y values, but we have to switch the actual variables when we've got an equation or a function. Next step is to solve for the new y. So this is back to those ones where we had to figure out how do we isolate the y. If I want to get that y on its own, seems to me subtracting 3 would make those guys cross out. So I'd have x minus 3 equals y. And the very last step, this is the fancy part. For our final answer, we're going to replace that new y that we just solved for with f inverse of x. So that f to the negative 1 power, you say it as f inverse of x. And remember, the x just says what the variable is that we're using. So if I switch this to an f inverse, I'm going to just write it first. So I'm going to say f inverse of x for this example equals x minus 3. So we started with this equation, and this is my inverse. And it all comes down to switching your variables and solving for your new y. That was a simple example I gave you just so that you could see what we were doing. All right, so let's do one more example. Let's do, what do we have? Any good ones? Oh, just a couple, huh? Let's do b, because it's got a fraction in it. So f of x equals negative 1/2 x plus 11. Our directions say to find the inverse of the relation or inverse of the function. So I'm going to replace that f of x with a y. I always manage to put my negative in the numerator of a fraction for some reason. After we change it to a y, and some people are going to want to do this all in one step, switch your variables as well. So the x becomes a y, the y becomes an x. And now we want to solve for our new y. So think back to that section. First thing it looks like would be easiest to get rid of is minus 11. And put that line down the middle if you want to, so you can keep track of everything. Over on the left, I've got x minus 11, not like terms. Over on the right, I've got negative 1/2 y. This is where I'm going to ask you now to do the reciprocal. So many of you are probably thinking to yourselves, yep, I'm going to divide by negative 1/2 on both sides. But now we've got a really awkward looking answer for our inverse function. So what we're going to do, instead of dividing by negative 1/2, we multiply by the reciprocal, negative 2 over 1 or negative 2. So I'm going to times by negative 2, times by negative 2. I'm going to put parentheses around that so I don't forget to distribute. Because if I times by negative 2, I have to times everything by negative 2. So those guys cross out, so I've got a y equals y. Over on this side, I've got negative 2x plus 22. Watch your sign. And the last step, it said to replace the y. What are we putting in place of the y? Just to make it fancy, right? We're going to do f inverse of x equals, I'm going to just put this on the other side because it looks more answerish that way, negative 2x plus 22. If you put negative 2x plus 22 equals f inverse of x, you would absolutely be right. Just looks a little awkward, but it's the right answer and you did all the work right. So this is our inverse, and this is our original function. So we found the inverses of ordered pairs, tables, graphs, and equations. So lesson summary, here's what you need to do in your own words. This one might tax your brain. How do you find the inverse of a set of ordered pairs or a table? What did we do for those first couple examples? How do you find the inverse of ordered pairs or a table? And for the practice problem, I'm going to ask you to think about the equation. Find the inverse of that equation. F of x equals an x minus 5 all over 6. Once you change the f of x to a y and flip-flop the x and the y, seems to me the first thing you'll be doing to isolate your new y is to times both sides by 6. That's it for section 4-7, the last section in this chapter. Have a great day. We'll see you next time. Bring your questions to class with you.